All right, so welcome to lesson 4, part 1, and we're going to talk about the logging module. We're going to do our lesson a little differently this time. Instead of being the traditional slides, we're going to do it, I'm just going to use a Python notebook, Jupyter notebook. So the logging module is used for reporting status, error, warning, general information, as well either to a file or to print it out to the screen in a different way than using the general print function. So the benefits of using this method is that it allows all Python modules to use the same logic. And this means that third-party modules or modules that you write when you build your complete system can take advantage of the standard library. There's a bunch of parts to the logging module that are pretty important. And the way it would work is that for the various parts, you would say that each module that you write has a logger, and the information is added to that log. And we invoke the logger. When we invoke the logger, so when we add either a piece of information to it, whether it be an error or warning or just general information, we would log a record. And then the logger can have multiple handlers. So depending on what you need, it could be writing the same message out to the user's screen for instantaneous feedback. You could have it write to a database. You could have it write to a file, and a whole bunch of other ways. So what we want to do is we're going to break it down into two groups, and we're going to look at a bunch of different things. So let's take a simple example, and our goal here is to have our log messages saved to a file. So here what we're doing is first we're going to import logging. This is a standard library. Like I said before, everybody has it. I'm just going to create a file name. And so this is going to, in the folder where this notebook is running, we're going to have this file logging _file _example.txt. And we're going to set some basic information using logging.basic_config. And this is sort of like a global settings here. We're going to say file name equals this log file name, which we instantiated before, and set the variable to, and then we're going to set our level, in this case to debug. We can then print out the message, and it should go to the log file. And then we can go back and we're going to read it and see what was put in that file, if anything. So let's go ahead and do that. So we went in, we it saved this message to our log file as expected. And from our file, we're able to see that we get debug. And notice it matched up to our logging.debug. It says root. This file should go in the log file as expected. So now we persisted information. So we could have multiple calls within our module that are that's grabbing our logger and writing that information out to the log file. So depending on where the error occurs throughout our whole program, it can capture that information in one spot. So it makes it easier to debug. And especially when you have headless scripts, so scripts maybe that run at a given time at night, maybe you're doing a database backup, maybe you're pulling down information from the web, massaging it and pushing it back up. You know, you're not going to be there when this stuff occurs. So logging is essential for those workflows. Now, right now we're just pushing everything to one log file, but these log files can get very big. And there's this concept of rotating log files. And this is going to allow us for the rotation of files based on size. So we can say when file A gets too big, go to file, now call it file B and keep adding the information to it. So it's going to rotate around and it's going to follow this pattern like over and over again, sort of like an array of numbers starting at 0 and going to n, depending on how many files you allow and the size. So we're going to approach it a little different. So this time I'm going to import logging again and the handlers. We're going to define our log file name, the base name, and we're going to get our logger. we're going to, instead of using the basic config, we're going to set it by the function set level. So we're going to get that same debugging level that we had before in the first example. We're then going to take our handler and define it, logging.handlers.rotate file handler, and provide the information. So we're going to provide our file path, the mode we want to write in. In this case, it's going to be write. The max number of bytes. This can be any number greater than 0. And the number of rotating files we can have. So for us, what we're saying is that in this file type, there can only be a maximum of 5. So if we have tons and tons of log messages, and let's say we make our log file size 5 megs, so that means at most your log file consumption is going to be 25 megs. So if we get to the 5th one in our backup file, and we hit that our 5 meg limit, let's say, it's going to rotate back to the first one and overwrite what was there. So you have to be cognizant. You want to make your logs and your rotation schedule big enough that it doesn't just keep running and overriding old messages. So you have to be aware of that when using rotating file. So we can, and then we add the handler to our logger. We're going to simulate some logging messages, close the handlers, and remove them, just so we can go ahead and erase the files and read them. Look for the various file names, and then print out the file name just to show that it was created. So let's go take a look. So here, because we made it so small, 20 bytes, the message that we put in was trivial, which was just, but we hit that 20 byte limit. So you can see the first one follows the pattern, but notice that each file below it adds a .1, .2, .3, .4, .5. So it did our rotation as expected. So this is just showing us that we can take our log and print it out and have it produce really detailed messaging for our programs. All right, so now we're going to go ahead and take a look at an example where we can apply this in a GIS context. So we're going to use a cursor object with logging, and we're going to set up some information that we want to capture as we move along. And we're going to stream it out to the user by using a stream handler, and then we're going to also save to our rotating file handler for our function. So here we go. We're going to do our imports. So let's go do that. So we're going to import logging, and then ArcPy DA and ArcPy in general. And now we have everything loaded that we need to work with. We're going to set up our basic configuration by first setting the level, and we're going to set the format. So we can specify what information we want appended along with the information. So some things that are really important are knowing when the error occurred, the name, what level of error it occurred, and the message. So here we can have the we have the date, time, name, the level, so if it's debug or info or anything like that, and the type of message. And then we can set the date format. So you might only want to know month, day, year, but it might also be helpful to have hours, minutes, and seconds, because maybe you have an intermittent problem, or maybe it only occurs at a given hour during the day. And it helps you develop patterns to find things that are going wrong. So you might think it's your script that's going on, but if you're dependent upon a network, maybe between the hours of 3 and 5 at your place of work, they take down the network to do internal upgrades. Or maybe between midnight and 12:30, there's the web service that you're going to always seems to go down, and you can capture this information and you can start seeing patterns and when things fail and how they fail. So logs are very powerful in that sense. So let's go ahead and run the configuration. Now we're going to set up our console logger. This is a different type of handler than we saw before when we were discussing. This is going to allow us to see how and modify the information that's streamed out to the user and how it looks on their console. So think of it about print, but we can add all this other additional information. So we're going to do console.stream handler. We're going to set our level on our console stream handler and then add it to our log. And we're going to set up our rotating file handler similar to what we saw in the basic config. So we're going to have our basic name be demo error.log. The max bytes is 2e to the 6th. Number of backup counts 10. And we have our log level as debug and the format that we want. And then we add that handler to our log handler. So now we have our two set up. Now we can go ahead and we can push some test data into it. Notice this time when we printed our messages, we got it actually printing out to screen, which is the first time we've seen that. So we have our date level, the name of our logger, the type of information, and the message that went along with it. So we have for debug, we expect the message debug, the type debug, and everything, and so on and so forth for each type coming through. Notice this didn't cause an error though, even though we did put one as an error. So this won't interrupt our logic workflow for our code. All it does is report that an error has occurred. So a lot of times this would be used in conjunction with a try except pattern, either just before an exception is raised or after. And you usually would take that information with error and put it in there. And then info and debug you would probably use if your info is just general info. So maybe you want to see that the process succeeded and have some messaging with it. And debug would be a mode that you would probably set within your program to say, I'm having problems, turn on debug mode, and debug mode would it would log all these extra messages. So every step of the program, it would probably push it out to the file or to the display. So let's look at this program and here. So now we're actually going to use it with our cursor object and how we can do this. So we have our log and we're going to first put in our info, and it's just going to be a general informational piece where we're going to do log.info, and then we're going to access our spatial data set. We're then going to go ahead and create our cursor. So da.search cursor, bring in our information, and go ahead and run it. We're going to gather our field names, get the index of our FID because it's a shapefile, so our object ID field. And then we're going to put another informational log message that says the spatial data set has the various fields. Then we're going to go through, get the object ID, let everybody know that we're looking at the current object, so it actually went through and looked at that record. And then we're going to throw a custom error, so if OID goes above 100, which shouldn't happen, we're going to throw our custom error. Notice this time we are capturing it as an arcpy.execute error. ArcPy has built-in errors, and the main one that you want to use is arcpy.execute error. And then we're going to use within the try except pattern, we have our try, so this is where our general logics run. And then when this error is raised, we set up multiple accepts. So when we have accept arcpy.execute error as AE, anytime this is raised, this workflow will work. So we're going to go in, say that we had a geospatial error, put the message in to our log, and then exit the loop. For every other exception, we're just going to say error and then put the message in and save the loop. So let's take a look at what that looks like. So we can see a whole bunch of messages came through. We hit our 101st record. Our geospatial error was raised and then added to our ArcPy stream log message. So that's an example of doing our custom error handling, what we have here is we've put our information out there, we have it saved, it captured our errors. Now, this is a trivial example, but like I said before, think of this at scale. As we build out systems, this information needs to be there so you know as you go through, it can be saved to your to the proper areas. So maybe a system admin or somebody else who's trying to debug these problems can capture this information. So this is the end of part 1.